Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day to each and everyone. So this is Sir Hanif, your instructor in E224. The description of this subject is electronic materials and devices. Okay, so we're basically tackling about the electronic circuits and its implementation. Okay, and the characteristic that is being associated with these um, devices. Okay. So before that, no, I have not yet given you an orientation regarding this subject, but the rules and regulation is the same with the other instructors that you have already have. No, the but you have already have. Then what I'm having to point it out here is the percentage and percentage of the different activities that we can have. No, the first what we have here, the first one is the prelim. The prelim is 20%. Okay, the midterm is 20%, the final is 30%, and for the remaining 30% is for the quizzes. We have quizzes of 20%, and 10% is for the attendance. Okay, so the passing rate here is 60%. Okay, so please be careful or um, having your passing rate, no, to this subject, in this subject. Okay, so once again, no, lahat naman ng rules and regulation is the same, no, with your instructors. But the other activities, rules for the other activities shall be announced in my activities, no, if I have. So um, the only important is yung yun nga yung na mention ko kanina about the percentage of the activities. Okay, that we will have. Okay, so let us proceed, no? So we have here a EE224. This is electronic materials and devices. Okay, the first topic that we have here is the semiconductor, or specifically the diode, no? The content of these topics are the following. We have here the what are the diodes made out of, no, the n-type materials, the p-type materials, the p-n junction, the bias p-n junction, the properties of diode, and the diode circuit models, the q point, the dynamic resistance, the type of diodes and their uses. Okay, so throughout this discussion, you will know how diode is being useful in different application. Okay, the importance of that diode and its advantage and disadvantage. Okay, and its basic characteristic. Okay, so we have here what are the diodes made out of. So the diode is made out of silicon and germanium. So these are the two most common single elements that are used to make diodes. A compound that is commonly used is gallium arsenide, no? So yan yung minsan na ginagamit, no, commonly used, especially in the case of lead because of its large band gap, no? So it can grasp a higher band uh, na photons to have a higher na light. Okay? So we have here the silicon germanium are both group 4 elements, meaning they have 4 valence electrons. So that's why they are used as they are used in diode, no? So their structures allows them to grow in a shape called the diamond lattice. Okay? So if you will think of how they are arranged in a lattice, so they are same as diamond na lattice, no? So gallium is a group of 3 element naman, while arsenide is a group of 5 element, no? So it means that for gallium it has a um 3 valence electron, and for the arsenide it has a 5 valence electron. When put together as a compound, uh, gas creates a zinc blende lattice structure. So, so I'm assuming that all of you have already known, okay, these names here that I am mentioning. No, so for example, is this valence electron. So I'm assuming that you already know about this one from your chemistry. No, so in both the diamond lattice and zinc blend lattice, each atom shares its valence electrons with its four closest neighbors. This sharing of electrons is what ultimately allows diodes to be built, no? So sharing of electron talaga, no? When dopants from group 3 or 5 are added, no? So silicon, germanium or gallium arsenide is changes the properties of the material. So we are able to make a P or N type materials that become the diode. Okay, um, so that's why, no, in this diode we are using silicon, germanium or gallium arsenide because of their valence electron. So they have the ability to share an electron, which lets them to have a P or N type materials na characteristic ng isang diode. Okay? So this diagram shown above is the two-dimensional structure of the silicon crystal, no? Um, so as you can see here, they have um, four bonding electrons, no? Each of them has four bonding electrons. Okay? So the height gains times represent the electronic bonds made when the valence electrons are shared. Then each silicon atom shares one electrons with each of its four close neighbors so that its valence band will have a full S of electrons. Okay? So yun. So that's why in here we are using silicon and germanium or gallium arsenide as an element or as a materials that to form a diode. Okay, so what is n-type materials? N-type materials are when extra valence electrons are introduced into a material such as silicon, an n-type materials is produced. So the extra valence electrons are introduced by putting impurities or dopants into the silicon. Then the dopants used to create an n-type materials are group V elements. The most commonly used dopants from group 5 are arsenide or arsenic, antimony, and phosphorus. So ibig sabihin nun, if if you will introduce an additional uh, electrons or dopants in a silicon or the elements that are used in forming diode, okay, so we can form a p-type material, I mean n-type materials. Okay, so for example is this one, no, as you can see here, yung isang materials dito have its 5 electron valence electrons. So this is called as a n-type material, no? So the two-dimensional diagram of the left shows the extra electron that will be present when a group of 5 dopant is introduced to the material such as silicon. This extra electrons is very mobile, no? So it can transfer from one atoms to the other, no? So yun, very mobile siya. So dito tayo sa p-type material. For the p-type materials naman, okay? For the p-type materials naman, when extra valence electrons are introduced into a material such as silicon, an n-type material is produced. Okay? Uh, the extra valence electrons are introduced by putting impurities or dopants into a silicon. The dopants used to create an n-type materials. Okay, wait. This should not be the definition of the p-type materials. I think this is um, technically error, okay, when I was inputting all the information that we have. Now, this should be the definition for n-type, but anyway, For the p-type naman, it is an opposite of n-type. So it has a hole, no? Instead of dupants, it has a hole, no? Ibig sabihin nun, it has a an area should be filled by the valence electron na hindi pa na-fill, no? So if you will take a look on this one, the other atoms has its four electrons, but the um, atoms at the center, it has only a three electrons. Okay, so it means that this type of materials is a p-type, no? P-type material. Okay, so the opposite of the other one. So dito tayo sa p-n junction. Okay, um, dito tayo sa p-n junction. So if you have a p-type material and n-type material, okay, the made range between them is called as a E field or electrical field, no? So the space this is composed of a space charged region, no? So if you take a look at this one, we have here the sodium and the another, I mean Na and Nd pala, no? So these are not the kuan pala. Okay, so between them are the electric field that is formed by the p-type materials and the n-type materials. Okay, so we have here the steady state when no external source is connected to the p-n junction. Okay, diffusion and drift balance each other out for both the holes and electrons. So at the initial condition, when there is no other external field here, no, dito sa dalawang p-n junction na to, the drift, okay, of these electrons here are equal, no? Ibig sabihin, this is totally balanced, no? So there is no external uh, forces that would happen, okay? So, okay, wait lang ah. Okay, so we have here space charge region, also called as the depletion region. So this is called as the depletion region. This region includes the net positively and negatively charged region. Then the space charge region does not have any free carriers. Then the width of the space charge region is denoted by W. Okay, in p injunctions formulas, no? So, 'di ba kasi nga in a electric field, no, based on what we have learned in our physics, if you have this p, 'di ba, p injunction as I have said here, and n material, p-type material and n-type materials are positive and negative, no? Positive and negative. Now, if you will, from our basic physics, if we have that one, the 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 charges inside this region here will be balanced, no? So the negatively charged will go through this part here, and the positively charged will go to this part here kasi nga na-attract sila, no? The negatively charged is attracted to these p-type materials, and the positively charged is attracted to this n-type material. So initially this is the condition of this material, no? So so if there is an external force here, no, anyway we will be tackling that one from our second topic. If there is an external force or external potential difference between this PN junction na to, okay, there will be a movement, or the drift is no longer equal, okay, to this junction here, no? So we will be tackling about that one next on our next meeting, okay? So but take note that this is a steady state, no? For this case, it is a steady state. Okay, we call this one as a steady state because there is the external potential difference that would exist on this material. Okay, so if you have any question about this discussion, please ask it to me right away, or um, please read further about this topic. No, okay, so that's all. good day and please keep safe. Okay, so assalamualaikum warahmatullahi wabarakatuh.